Welcome back, everyone. This is part 2 of the Magellan GPS L9400 LM Magellan RoadMate. As you know from the first video, it's dead in the water, and we did some testing. Today I have the screen removed because I'm hoping that it's not the screen itself, but as you might be able to see here, this is the plug-in here, the DC power plug-in. It's a common plug-in for these sorts of units, and I'm thinking this unit right here, the plug may be damaged. So what I'm going to do is I'm going to see if I can find a connection between here and the battery. I'm not exactly sure which is positive or negative, but if I switch it to ohms, it's not really going to matter because we've tested the battery. There's no power on it, so we just need to find out what's positive and what's negative right now on this terminal. Sorry about that. So there's 2 points here on this side of the plug-in and 2 points here on that side of the plug-in. Not exactly sure why, but I guess it's a continuation to the circuit board, and there are some circuit board tracings here, but I'm thinking something here along these points has to go to the battery. If not, the battery will be able to take a charge. So let's check our ohm meter. It's good. Okay, let's just root around here on the battery and see what we can find. That's negative, and we have 3.84. Yeah, so we're getting some sort of reading there. We'll go to the white wire. No reading. And we'll go to the black. No reading. So this side must be the positive side of that battery. Let's try it again. We're getting a reading. Okay, let's try to point up ahead. Same thing. So this is obviously a direct connection. Let's try the negative. And we have no connection. Let's try the white wire. No connection. Let's try the red. And we have a reading. Of course, it's not beeping, but there is some sort of connection there. We are getting a resistance. The question is, should that be beeping outright? Should it be a direct connection? We'll check between this side and that side, see if we get anything. Okay, we're getting a reading right across that. So it's difficult really to say what we could do from here on in, because obviously there's a path between here and here. And I was going to make a connection positive, negative here, like this. Should have it this way, of course. Positive and negative wiring to a battery or my variable power supply, and turn it to about 4 volts and see if this would power up. But I'm not quite understanding why I'm getting a resistance here. So this may slow down my progress on the repair of this. Now, that being said, I could put 4 volts here from the variable power supply, put it in 3.5 volts, whatever it is. I think it's 3.7 volts DC. I could put power in there, just register the voltage. I just have to check now my power supply to confer to if it goes down to 3.7 volts. I think it only goes down to 6. I'll be right back. Okay, this is the lowest that my variable power supply will go down, 6.45. So I don't know if I want to dump that into that battery. So I got to try to figure out some other way now to get power into power up this unit. Okay, I have found a battery that came out of a Nokia phone, and as best I know, I had a couple of these old phones. I got a bunch of them actually, of different varieties. But I kept the batteries. They're lithium-ion batteries, rechargeable, and they really keep good charge. So, just going to test this battery to see if there is power left on it, and I'm pretty sure there is, because let's see the positive here, and difficult to hold. And if you look at the meter, you'll see 3.3. When I first put it on, what is it, 3 point something? It's draining down pretty quick though. Interesting. Not exactly sure if this is going to work, but there is power on this battery. I have several of these batteries, so I'm going to go ahead now and solder. It's actually labeled positive and negative, and the center pin must be where the white wire would go. And we're going to give that a go. Okay, I have the 3.7 volt Nokia battery wired up. We have green on ground, orange on the positive, and white on the white wire, which is a neutral or whatever, not sure. So now I'm going to test with the meter. I'm going to bring the meter in. Got to be careful because the solder points aren't absolutely the best. And we have it on DC volts, and now we're going to test here at this point here and see if you got that in the shot. Have I got that in the shot? I think I do. Let's see. Without blocking. Here's ground. I'm a fair distance away, so this is a bit awkward. So we got 3.6 volts. If you can see that on the meter, which I think you can. Yes, you can. Okay. I'm going to reinstall the ribbon cable now, very carefully. I'm going to tape off this section here so it doesn't get grounded out, and we'll come back and see if this is going to power up. Okay, we have the screen plugged back in. I'm going to remove the meter here so I can get access to this here. Just pop this off so you can see what's going on here. We have the ribbon cable back in, as you can see, and the wire terminals that we soldered are taped so that they won't move, and we've confirmed that there is power. So just going to place this down here lightly. The power button is on this side here. So here goes. You see the power button right here, and I'm going to turn off this light. Oop, battery fell out. Turn off this light here, fluorescent. You may hear a bit of a buzz when I'm doing videos here. That's probably the fluorescent making that noise. So here we go. Will it power up? 3, 2, 1, and press and hold. Nothing. Try again. Press and hold. It says to hold for 3 seconds and the unit should power up. And nothing. Third time. Press and hold. And nothing. Confirm that there's power going to the unit. So now we have to say, even though this connector may be bad, it's possible the screen itself, it's totally wiped out, gone, blown. And maybe the ICs, there's one here and one there, and I'm sure there's more that we haven't discussed yet. So it looks like it's going to be part 3 if I can figure out what step to take next. But obviously it's not the power supply, I mean the battery. We have 3.7 volts now running into the circuit board. So I'm going to stop now, and hopefully if I come up with an idea, I'll get back to you with step 3 where we can repair this GPS. Thanks everyone for watching.